right, so now we're going to try to do an example with the inverse of the convolution property. So where we think about how if we take L inverse of the product of two functions that depend on S, then what we're actually looking at is the convolution of their inverses respectively, which depend on T. And to do this, we're actually going to go back to that prior example right here, 4.4.2. We're going to pick up right here, and we're going to use this other property to compute little x of t instead. So we're back to 4.4.2, and we found x equal to 1 over s squared plus 16 plus s over s squared plus 16 squared. We know that x of t is going to be the inverse Laplace transform of that, but we need to be able to find those different pieces. And so with linearity and sort of noting that, oh shoot, turned off the screen again. Noting that L inverse of 1 over s squared plus 16, we follow the same process as before, and we know that that's just 1/4 sine 4t. Really the thing that we're going to be focusing on is L inverse of s over, actually, you know what, there's no harm in me writing out that full thing, just in case you can't remember when we were doing that a little while ago. I mean, it's only a little while for me. It could be days for you. Nothing to stop you from spreading out the videos that way. Okay, so L inverse of 1 over s squared plus 16 is just going to give me 1/4 sine 4t. And really the thing that I'm worried about here is this L inverse of s over s squared plus 16 squared. How are we going to find that is the real problem that we're focusing on here. And so what we're going to do, before we recognize that that was a derivative, and it took us a couple steps to fill in all the details for that, now we're going to say that that's a product of two functions and see what happens. So that's 1/4 sine 4t plus L inverse of s over s squared plus 16 times 1 over s squared plus 16. So the two denominators multiplied together gives you that s squared plus 16 squared. S times 1 gives you the s on top. So all I've done is separate out that one function into a product of two functions. But now I know that 1/4 sine 4t. If I go ahead and I want this to look like the product of two things that I know the inverse Laplace transform for, I know that I want this to be s over s squared plus 16, and I want this to be 4 over s squared plus 16. So I'm going to go ahead and divide by a 4 to even that out. And then I can see really clearly that this looks kind of like a cosine 4t, and this looks like a sine 4t. So I'm going to have 1/4 sine 4t plus 1 over 4, and then I'm going to have L inverse of that quantity star L inverse of that quantity. But that's just going to be cosine 4t star sine 4t, where that star denotes convolution, not multiplication. And so from here, I have to compute that convolution. And since there's two trig functions here, it's actually going to be a little bit lengthy. So I'm going to go ahead and write that definition right here, and then in the next video we'll actually pick up and compute that convolution. So this is going to be an integral from 0 to t of, which do I prefer to have first? Let's do the sine 4t first. So sine 4 tau cosine of 4 times t minus tau. Integrated with respect to tau. What you might notice is just now I went ahead and changed this to cosine 4t sine 4t like this to match the order that the convolution definition comes in. That's okay. Products can change in either direction. There was nothing that made me put the s before the 1. I could have just as easily done this back early on in the problem. So the order that you write things inside your convolution integral doesn't matter as long as you're consistent. So we'll compute that integral in the next